the number is talking about the second element, not the iron. It's talking about oxide.
No, it's talking about iron, because these are the number of electrons iron lost to the second element or to the other ion, whichever the negative ion is.
So it's just a bond.
Yeah, it's exactly, to be exact, it's an ionic bond.
Yeah, okay.
So these are the number of electrons the metal, the transition element, is losing to the negative ion, or actually giving to the negative ion.
Okay.
Okay. All right. So let's raise it up. Next part.
So I had, in order to get the 1 mark, I had to write hydrated iron 3 oxide.
Right, because that's the complete name. Miss any part of the name and it would be considered incorrect.
Okay. Okay. Then what type of reaction occurs in the rusting of iron? It's oxidation.
Perfect.
Yeah. Okay. And some iron objects are coated with a layer of zinc to prevent rusting. Name this type of rust prevention. You can either call it sacrificial something or galvanization, I think. Yeah.
Yeah, both names are correct.
What's
But
the first one? Sacrificial.
okay,
I forgot.
if there is specifically zinc mentioned in the question, I would rather ask you to prefer galvanizing as an answer. But you may also write sacrificial protection, since zinc is more reactive, iron is less reactive. Sacrificing a more reactive metal to save a less reactive one from rusting makes sense of sacrificial protection. That's all what sacrificial protection is about. So both of them are correct answers actually, but I tend to ask my students to go with galvanizing first, since galvanizing specifically occurs with zinc.
Okay.
So moving on.
Explain how this type of rust prevention continues to protect iron when the layer of zinc is damaged. Zinc is damaged. Okay. So basically, if the zinc reacts with all the oxygen and the surroundings, which protects the iron.
Right. But that would
And it
only get
says,
you 1 mark.
and so the iron is not affected. Would that be the second one?
That would be the second one. That's right. But a more clarifying answer would be better. For this kind of question in which you have more than 1 lines, and that's more of an explanation question about how or why some process is occurring. So in this case, I ask my students to write at least 3 points. Let me go with the points in order. The first one is that you should or must mention that zinc is more reactive than iron. Secondly, you should mention that zinc will lose electrons in preference to iron, which means zinc is pretty good at losing electrons as compared to iron. And of course, the third point would be the one that you explained, that in this case, zinc would react with all the oxygen and the water vapors surrounding the entire portion of iron. And even when the layer is damaged, zinc would keep on rusting and iron would be saved. So iron would not rust. And that's the third point.
Okay.
So writing all 3 is a better idea than writing just 2.
Okay.
And
So
remember,
first,
if you don't mention zinc being more reactive than iron, you won't be answering specifically the last part of the question, which says that where the layer is damaged, the rust prevention continues. So it continues because it's more reactive. Since it's more reactive, zinc keeps on rusting and iron is saved.
okay, yeah, that makes sense. Okay.
All right.
Okay, then.
Okay, so moving on to the next page.
Give two other methods used to prevent iron from rusting. Remember you can paint it. That also
R-
prevents, and
Right. And second,
the only two I'm sure of is painting and galvanization. I don't remember a third method.
okay, there are painting is actually more of a barrier technique. You create a barrier between iron and the surrounding oxygen or in the air or water vapors in the air. In order to put up a barrier, painting is not the only technique. You may use oiling, you may use a layer of grease, you may cover it with some plastic sheet. So there are many methods of creating a barrier.
Okay.
Otherwise, apart from galvanizing, sacrificial protection, you may also electroplate it with different elements, such as you may electroplate iron with tin, you may electroplate iron with chromium. Remember, we made an alloy of iron with chromium by the name of stainless steel,
Yeah.
which actually had a pretty good property of not getting rusted. That was because chromium was a part of the system. So, electroplating can be one of the techniques. Alloying can be one of the techniques. Apart from galvanizing, sacrificial protection, oiling, greasing, painting, covering with plastic sheets. So there are many methods given in your book.
Okay. So oiling, painting, and the electroplating.
Right.
Okay. Can I add it on the screen and write, or will it not save?
I didn't get it. You want to write it on the screen? That's fine. Go ahead, annotate it.
Yeah. Or I can do that on my own copy. Yeah. Never mind. I'll answer it on my own copy.
Okay. Because if you annotate on mine, it won't be saved. As soon as I go to the next page, I might need to remove it. So doing it
Yeah.
on your own copy is a better idea. Okay. So this finishes question number 2.
Previous question. And the 3 points you told me for the previous question, it was zinc is more reactive than iron, so it will so it will react with the surroundings. And was a third point?
No. Actually, react with the surroundings was the third one. The second point you're missing in between was zinc lose electrons in preference to iron.
Okay.
It has a better capability of losing electrons than iron. That's why it can react with the surrounding much faster than iron can. Or you can simply say zinc rusts, but iron does not.
Okay. So we move on now. Okay.
Yeah,
Question
sure.
3. So to complete this table, correct with from the box for each change of state, solid to liquid. Okay, wait. This out. Okay, so solid to liquid, that would be melting.
Right.
Solid to gas, that's solid to gas. That was sublimation, I think.
Right.
And then liquid to solid is freezing.
Good.
Okay. Okay, the next question. Oh, okay, when ammonia gas and hydrogen chloride gas mix, they react together to form a white solid called ammonium chloride. The equation for the reaction is NH3 gas plus a hydrochloric acid gives NH4Cl. Okay, ammonium chloride. Okay. A teacher soaks a piece of cotton wool in concentrated ammonia solution and another piece of cotton wool in concentrated hydrochloric acid. The teacher places the two pieces of cotton wool at opposite ends of the glass tube at the same time. After several minutes, a white ring of solid ammonium chloride forms. Okay, that's the image. Okay. And the question is, state the name given to the spreading out of gas particles. Spreading out as diffusion.
Right.
Wait, edit. State how the diagram shows that the particles of ammonia gas are traveling at higher speeds than the particles of hydrogen chloride gas. So this is shown as the white ring is closer to the side of the hydrochloric acid.
Yeah.
Would that be the answer?
Okay. But you need to be more clear. You're right with your answer, but the clarification is not good enough. I
It's a
want you
1 mark.
to choose better words. Yeah, you're right about the marks, you're right about the answer, but I simply want you to choose better words.
Okay. Okay, let me think. So, particles of ammonia gas are traveling at higher speed. Particles of hydrochloride. Hmm. Because um, so if they reacted and the wiring is closer to the hydrochloric acid side, that means ammonia had to travel a longer distance than the hydrochloric acid, and they reach there in the same time.
Right. Now you have chosen the right words I wanted you to. Good, good, well done. Let's move on to the next one. Mentioning that which one has covered greater distance than the other is the right way to do it.
Okay. Okay, let me just type this out and answer it there with the
Sure,
full verb.
sure. Take your time.
Yeah. All right. Um,
Part 3 then.
Yeah. Let me see. So gas particles travel at high speeds. Yeah. And give a reason why the white ring of ammonium chloride takes several minutes to form. Ooh, several minutes to form. High speeds. Would it be because ammonia isn't very reactive, so it would take longer?
No, it's not that. It's about the gas and its motion. Actually, both the gases are reactive enough to do the reaction in a fraction of a second or a couple of seconds, but it takes several minutes.
In several minutes. So it mentions the gas particles travel at high speed. So would that mean it takes longer to reach to the ring? Is that it?
Right. And why does it take longer? That's what he wants to ask.
Gas, gas particles move in a random order, so it would be hitting the walls of the tube.
Right. Now you're doing it correctly. So because of the
Uh,
random motion, they're not exactly traveling in the right direction. They're hitting one another. They're hitting the walls of the container, the gas tube in this case, glass tube in this case. So yeah, because of this random motion, it takes this much time. Mentioning random motion would be a great way of answering this question.
Alright. Okay, next question.
Right.
Concentrated ammonia solution and concentrated hydrochloric acid are corrosive. Give one safety precaution a teacher should take. So if it's corrosive, it should be handled carefully. So you can use gloves, I think.
Right.
Would that be a safety precaution?
That would be a safety precaution. But remember, whenever we are talking about safety, uh, all of the safety gear that is required for a single experiment must be mentioned in a single go. For example, the teacher shouldn't just take the gloves. He or she should also use the goggles
Also use what?
or may goggles
Oh yeah,
means eye
okay.
protection gear, face protection gear, hand protection gear, goggles, face mask, or a face blocker, maybe a glass wall, maybe a fume cupboard, along with the gloves would work better. So you can mention a couple of safety procedures or precautions instead of just mentioning one. It's always better to mention more than one if the experiment requires so, of course.
Uh,
So mentioning glass wall or maybe goggles along with the safety gloves is a good way to write the answer,
So I should mention more than one, even when they ask for one, or
even when they ask for one.
okay, yeah,
Because let me explain. A safety precaution is to use a safety gear, not just to use gloves. Safety gear means you try to complete all the things that you require for one experiment, not just one part of it. Gloves are just a part of it, not the entire safety gear. And remember, when you're going to go for an experiment, you're not just going to protect your hands. You would also like to protect your face, your eyes, right?
yeah,
So that's why. Even if it's one safety precaution, it includes all the safety gears that you require for one single experiment, be
yeah.
it gloves and mask and glass ball, whatever that is.
Okay. So we move on to the next question.
Question number 4 then.
Yeah, okay. Okay, so a teacher uses this apparatus to find the percentage of oxygen in gaseous mixture of oxygen and argon. Okay. Um, this is a teacher's method. Step one, heat the copper powder. Step two, push the plunger on syringe A to pass the mixture of oxygen and argon over the hot copper so that the mixture moves into syringe B. Okay, that's A. And then push the plunger on syringe B to pass the mixture of oxygen and argon over the hot copper so that the mixture moves on into syringe A. And then record the reading on syringe A. Repeat steps 2, 3, and 4 a number of times. Okay. The volume of gas decreases as oxygen reacts with copper. Argon is unreactive, so does not react with the copper. The copper powder turns black. Give a reason why the powdered copper powder is heated. Okay. So would this be just to like make the reaction happen faster so the copper particles would have more energy?
You can answer in this way, but it's more about the reactivity of metal. And in case of copper, we know copper is very unreactive. It does not react under normal conditions. So we need some harsher set of conditions in order for copper to react. And yes, of
Okay.
course, the background information does require the student explaining that this would give copper enough energy to react.
Yeah, so what would
So,
the
so a
answer be?
perfect answer should include a couple of points. Number one, copper is very unreactive under normal conditions. It
Yeah.
reacts under harsher conditions when copper atoms have enough energy to react. This would consume both the lines, but this would be a perfect answer, explaining to the examiner that you understand the reactivity of metals as well as you understand the fact that heat is sometimes required to initiate the reaction, not to just fasten it up, which is definitely not the case over here.
Okay. So I wrote the answer.
All right. Up next.
Mm, yeah, okay. State why argon is unreactive. Oh, reactive. Is it because they have strong bonds, therefore it would require more energy to react with?
Actually, argon does not form any bonds.
Oh, so, so yes. Wait, let me look at the argon on the periodic table.
Good idea.
It's not there. Oh, it's it's in group 0, that's why.
Right.
So full outer shell, okay.
So this also gives you the idea to look up the element in the periodic table before you start writing or thinking of the answer. This sometimes helps.
So I just need to mention it has a full outer shell for the mark, or
Right.
Yeah.
Full outer shell, complete octet, any of these lines would work.
Okay. Then give the name of the black powder that forms when oxygen reacts with copper. Oxygen reacts with copper. And it's black powder. Um, I don't think I know this.
So what do you think would form when oxygen reacts with copper?
Copper oxide.
Okay, but copper is a transition element, and since it's a transition element, we need to mention its state.
It's state.
Try working
Copper,
out how many electrons would copper lose
copper two
to oxygen.
oxide. Two.
Copper, right, copper to oxide. That would be the
Yeah.
correct answer.
Oh, that's the answer. The black powder is copper two oxide.
Right, black
Oh,
powder
okay.
is copper to oxide.
Okay.
Copper compounds have many different colors, and it's important in Edexcel chemistry that you know and remember, you memorize those colors. Color of original copper metal, copper carbonate, copper sulfate, anhydrous, um, copper hydroxide, copper oxide. They all have different colors, and you're supposed to memorize those colors for exams because they are a part of exams. Most of the time they talk about any of these compounds for copper, since in this paper you would see they're talking about copper oxide for its color.
Okay.
And you would notice that they have been a part of past papers way too many times, which makes it important, of course.
Hmm. Okay. So I'll move on to the next question.
Right.
Uh, the table shows the teacher's results. Okay. State how the results show that all the oxygen has reacted. Towards the end, we see like a plateau. Therefore, there's no more reaction occurring.
Right. Perfect answer.
The volume of gas in the glass tube and connecting tubes is 175 centimeters cubed. Use this value and the results table to calculate the percentage of oxygen in the mixture of oxygen and argon. Oh, how can I use this? So we're given the volume and how to calculate the percentage of oxygen and the mixture of oxygen and argon. So, okay, let me try and work this out. 16. Hmm. Would there be 32%?
And how did you come up with the answer?
I'll just use the MRs and molecular mass, and then I add them together, and you get 56, and then divide that by 16.
Wait, what? What kind of working is that?
I'm not
Okay,
sure how to answer this question. I just made
okay.
something up on the
I'm going to
spot.
give you a small hint, and I want you to work your way over there. All right. Now, the entire volume of the gas in the glass tube and the connecting tubes is this. We started off with this much of the reading, and by the end, we had this much reading. So you would know the difference of how much oxygen was consumed. So the
Okay.
amount of oxygen consumed over the total amount multiplied by 100. I think that's pretty easy to follow.
Okay, so it's 11.4%.
Right, 11.4%. Makes
Oh,
sense?
so you meant to use the table. Okay.
Right. Because this part of the question only states the total value. Until unless you would know how much of oxygen you have consumed, you won't be able to calculate the percentage.
Okay.
Okay. You might need to go back and forth in the question to find out the values you need to use for a calculated question. So it's better to go through the question once again in order to find the values you're supposed to use. Moving on, last part of the question.
Yeah. Okay. Next question. Suggest one reason why the calculated percentage of oxygen in the mixture may not be accurate. Oh, maybe due to impurities, or some oxygen might have been lost, so might not have gone like in the table. The reading might have been wrong.
Okay.
No,
One
wait,
of
wait.
the reasons that you are correct with is that the readings might have been wrong, or we might have made a mistake in finding out the readings. Apart from that, the other two reasons are not solid enough.
Okay, so
There is a much better reason to this question than all of those combined that you've stated. Can you think of another one? The one I'm trying to point at?
um, reason. Wait, let me go back to the experiment.
Right. That's a good idea.
Seven. Maybe. No, I'm not sure.
Uh, Maybe because not all of the oxygen has reacted.
Okay, but in the
What?
previous question, we said all the oxygen has reacted because the reading is stopped.
Okay, that may be because we took a very more small amount of copper. Since the copper ended, the reaction also stopped. That doesn't
Oh,
exactly mean all the oxygen has reacted. That might mean that the amount of copper taken was too small for the oxygen to completely react with.
okay.
So the strongest reason over here would be that oxygen may not have been completely reacted, or all of the oxygen may not have been reacted, which again points out to many different directions. It may point out an error in the performance of the experiment. It may point out to the amount of copper taken much less than required. It may point out towards anything, but this far is good enough for you. Just writing the reason is good enough for you.
Okay. So we move on to question 5.
Right. Question 5.
Okay. So complete the table to show the relative mass and relative charge of a proton and neutron. Oh. Okay. So just the relative charges, that's easy. So and the relative masses of a proton and neutron is 1, right?
Right.
And then charge is +1 for proton, and it's neutral for a neutron, so just 0.
Just 0. Right.
Okay. And then magnesium has 3 isotopes. Say the meaning of a term isotope. An isotope is a same version of the same element with the same number of protons but different number of neutrons.
Right. Atoms of elements with same proton numbers but different neutron numbers.
Now, the next part, the symbol of an atom of one isotope of magnesium is that, okay, give the number of protons, neutrons, and electrons in one atom of the isotope. Okay, so protons, we can see it's 12, and then neutrons is just subtract that, so 26 minus 12 is 14.
Right.
And then electrons is the same as protons since it's not charged. So also 12.
Right.
Okay, we'll move on to the question. Next question. A sample of magnesium contains these percentages of the 3 isotopes. Okay, use this information to show that the relative atomic mass of magnesium is 24.32. Okay, so how do I do that? Do I just multiply 24 with 79 and then add 25 plus multiplied by 10 and then add 26 multiplied by 11 over 100?
Right. That is correct.
And
And
then
it should give you the answer 24.32.
yeah, okay. Let me just write the formula on here.
All right. Take your time.
Right, 79 plus 25 multiplied by 10 plus 26 multiplied by 11. And then divide all by 100. Okay. So the next part. 1 mole of magnesium has a mass of 24.32 grams. There are 6.022 times 10 to the power of 23 atoms in 1 mole. Calculate the mass in grams of 1 atom of magnesium. Give your answer to 4 significant figures, okay? Okay, that's simple. You just divide 24 and the number of atoms. Okay, so would the answer be 4.038, 0.39 times 10 to the power of times 10 to the power of negative 23?
That's right. If this answer comes out from dividing 24.32 by 6.022 into 10 raised to the power 23, that is right. Plus, you have already answered you in 4 significant figures, so this seems correct.
Yeah, okay. 6.022. Okay. The equation for the reaction between magnesium and oxygen is 2Mg plus O2 gives 2MgO. Okay, determine the maximum amount of moles of magnesium in moles of magnesium oxide that can be produced from 0.5 mole of magnesium and 0.2 mole of oxygen. Okay. So oxygen is 2Mg 0.222. Okay, I'll work this out on my notebook.
Sure.
Hmm. Can you help me out with this one? Because I think I'm overthinking this whole process. Is it just 0.5 plus 0.2?
No, of course not. It's not like that. In this question, you have masses for both, moles for both the reactants,
Yeah,
for magnesium as well as for oxygen. So you need to find out between both the reactants, which one is the limiting, would end up earlier and stop the reaction, which one is in excess. And from there on
oxygen.
onwards, you need to calculate the maximum amount in moles of magnesium oxide that can be formed from the limiting reactant, from either one of these pieces of information, not from both.
Okay, so
Do you remember how
oxygen
to do
would be
that?
the limiting, right? Oxygen is a limiting one since there's less.
Okay. Are you hinting the zero point 0.5 and zero point 0.2, and the zero point 0.2 means this is less in amount?
Yeah.
This may not be the case every time. You're lucky this time this is the case, but you don't simply take it from the values. Now, let me point it out how this works. Clearly, you are a little bit getting about how we are supposed to do this. Now, we can write either of the ratios. You can write oxygen first, you can write magnesium first. It's entirely up to you. Since I've written magnesium first, let's take the values from the equation. 2 moles of magnesium are required with 1 mole of oxygen in order to work the whole equation out. So 2 moles of magnesium, 1 mole of oxygen. How much of the amount of magnesium is present? 0.5 moles. Since it's 0.5, we'll find this one out. This one would be 0.5 over 2, which is equal to 0.25. As this amount is more than what's given in the question. So definitely we have less oxygen than what we require, which means this is the limiting reactant, and which means this one is the excess reactant, right? So magnesium is in excess, oxygen is in limiting amount. If oxygen is in limiting amount, we need to compare oxygen with the product, because that's how our calculation is supposed to be correct. If we're going to do it magnesium ratio MgO, that would be wrong, because any ideas or any calculations made from excess reactant are wrong. Now let's take a look at the equation. 1 mole of oxygen produces 2 moles of, sorry, my bad. 1 mole of oxygen produces 2 moles of magnesium oxide. So 0.2 moles would produce what? X, and X is 2 into 0.2, the answer to which is 0.4 moles.
Okay.
All right?
Oh. I got confused at the start only, like when you find 2.2. When you got Mg2 in the ratio with oxygen.
Okay, you can do it this one with any way you like. I took the values from the equation, then I used one of these values. You can either use magnesium's value in order to find the value of oxygen required, or you may use oxygen for the value of magnesium required. I can also work the other way out. For example, I can put oxygen first, magnesium after, take the values from the equation, 1:2, then take the value from the question, 0.2. This would give us how many moles of magnesium we require. Sorry, 0.2 is equal to 0.4 mole of magnesium is what we actually require for this reaction. Fortunately, we have 0.5 moles present, which means magnesium is in excess, again in the same answer, and oxygen is limiting. Every time I take a ratio like this between both the reactants, it gives me a pretty good idea that how much I actually require from this reaction and how much do I have. So if I have more and I require less, the element is excess reactant, right? If I have less and I require more, the element is limiting reactant. And remember, any calculations made from limiting reactant are correct. Any calculations made from an excess reactant are incorrect. Why? Because the reaction stops as soon as the limiting reactant is completely consumed.
Okay.
Make sense?
Yeah.
When we were doing this chapter, I gave you another example. I think I took the example from making of sandwiches, from loaves of bread, slices of bread actually, and kebabs.
Oh.
If you remember that example, it is much easier to understand.
I don't
Let's say
remember.
let's say you make a sandwich by putting 2 slices of bread together and a kebab in between. And let's say you have 30 slices and 14 kebabs, you would know that kebabs are a limiting reactant. They would end up earlier,
Yeah.
stopping you from making 15 sandwiches. Actually, the 15th sandwich to be exact.
Okay.
Okay. So what are you supposed to do? There are 2
Yeah.
steps
Okay.
that you need to follow in this question. The first step, you're supposed to compare in ratios both of the reactants. Since you have the information for both of the reactants in the question, it should be easy. Now, if you get a bigger answer and you have smaller amount, if you get a bigger answer and you have a smaller amount, like we did in the case of oxygen, it becomes the limiting reactant. But If you get a smaller amount and you have bigger amount available in the question, this proves the element to be the excess
You're
reactant, like
hello?
in case of magnesium. Can you hear me?
It's lagging again.
Okay, just give me a minute. And I'm going to change the internet connection. Just a second. Let me connect to my backup source.
Okay.
Okay, just a second. Okay, can you hear me now?
Yeah, it's better now.
Okay, so just a second. Do I need to pull up all the writing?
No, it's okay. I kind of understand it better now, but can you continue with the like kebab explanation? I kind of like that idea.
Just a second. Okay, so we were talking about this, and let me explain the idea I was talking about. Okay, so let's say you have 30 slices,
Yeah.
and let's say you have 14 kebabs, and your formula of a sandwich means that you require 2 slices plus 1 kebab.
Okay.
So how many
20,
sandwiches would you be able to make?
2 slices and one kebab. 14. 14 sandwiches.
And what would you still be left with?
You'd be left with 2 slices.
Right. And as soon as you go with the calculation, you get an idea that in this scenario, what is the limiting reactant?
Kebabs.
And the excess reactant is?
The slices.
Right. And if you make your predictions according to excess reactants, would your predictions be correct?
No. The limitants you would need to use.
Right. which gives you the idea that if you use the limiting reactant to make predictions about how many sandwiches you can make, your predictions would be correct. But if you predict according to slices, you might end up predicting incorrectly,
Yeah.
right?
Okay.
Because you would of course obviously predict 15 sandwiches when you look at the slices, but that's not the right idea. That's not the right answer either. So you need to
Yeah.
predict as per the limiting reactant. And that's what we are doing over here. Now, let me do it in terms of ratio. Now, it's pretty simple. If I take slices and I ratio them with kebabs, according to my equation, I require 2 slices in 1 kebab for every sandwich, which means that if I'm going to go with 30 slices, then how many kebabs do I require? 15.
Yeah.
Now, it tells me I require 15 kebabs, but I actually have 14, which automatically makes kebabs the limiting reactant and slices the excess reactant. So that was my first step over here. That's what I did over here,
Okay.
right? And then I
Yeah.
need to take another ratio. This time the ratio would be kebabs, and this time I need to take the product, sandwiches, right? So I need a kebab for a sandwich. And of course, if I have 14 kebabs, the answer would be 14 sandwiches. So that's the actual number that we are making. You did all of this calculation in your mind because it was simple, easy, somewhat attractive, and understandable. When it comes
Yeah.
to elements, we don't work with them daily. So it becomes a little confusing. It becomes a little hypothetical, a little difficult to work with.
Okay.
So the first step you're supposed to take is to take the ratio between both the reactants. Try finding out which one is limiting, which one is excess, and then use the excess reactant with the product to find out the exact number of moles of product you can form.
Yeah, I understand like the towards the end, like how to calculate the number of like the final moles, but I don't understand how to find which one's the limiting and excess. Or is that just a ratio, whichever one has a lower ratio?
Okay, that's just simply a ratio between both the reactants. You can put the either one over here. Remember, if your answer is bigger than the amount you originally have from the question, the thing on the right-hand side is the limiting reactant.
Okay.
If your answer is smaller than what you had originally in the question, the thing on the right-hand side is an excess reactant. As
Oh
simple as
yeah,
that.
okay, that makes sense now. Yeah.
Okay, it depends upon your answer. If your answer is bigger, you have actually less number of moles of the reactant, then obviously that's the limiting one. But if your answer is smaller, your requirement smaller, and you have a much greater amount to work with, then of course you have an excess of it.
Yeah.
Make
Okay.
sense?
Yeah.
I think now we have cleared the confusing part, right?
Yeah.
Good, good. So that means can we move on?
Yes.
If you want to note it down, you can. Go ahead. Take
I'll
your time.
take a screenshot of this.
Sure.
Okay.
Okay, so I'm gonna go back to the original paper now. This finishes question number 5 for us. Let's start with question number 6.
So this question is about sodium oxide. Yeah. The diagram shows the electronic configuration of atoms of sodium and oxygen. Okay. Describe the changes in electronic configuration of the atoms of sodium and oxygen to form the ions in sodium oxide. Okay. So sodium oxide. combination. So in this case, it would oxygen requires 2 more atoms and sodium needs 7. So would sodium lose 1 and
Right,
would there 1 oxygen and 2 sodiums?
right,
Okay. So in order to fulfill the outer shell of oxygen, it would require 2 atoms. So 2 sodiums would lose their outermost electron, which would lead to sodium having a full outer shell and oxygen too.
oxygen to gain 2 electrons. And
Yeah,
this completes your answer. Good. Make sure for 3 marks you mention all 3 things. First, sodium loses its outer shell electrons. Secondly, there are 2 sodium atoms, not just one, and both of them lose their outermost electron each in order to give oxygen 2 electrons, which completes the outermost shell of oxygen as well,
yeah,
right? So sodium loses an electron, each sodium atom loses an electron, and the oxygen gains 2 electrons in order to complete this bonding, which
yeah.
also completes all 3 marks.
Okay, next question.
Right.
Okay. Calculate the relative formula mass of sodium oxide, Na2O, using information from the periodic table. Okay, so oxygen is 16 and Na is 23. So 23 multiplied by 2 is 46, and then 46 plus 16 is 62. Yeah,
Right.
the Na
62.
6.
Okay, C part, next page.
Okay, next page. Explain why solid sodium oxide does not conduct electricity. Okay, solid sodium oxide. Has no free electrons or ions, therefore it cannot carry a charge.
Right, good.
Would that be the 2 marks?
That would get you 1 mark. Okay, for another mark, you need to explain why the ions are not free to move.
Sodium, because they have because they all have full outer shells, so they all the electrons wouldn't react or leave the shells.
No, I'm not talking about electrons. I'm talking about the ions. Why are the ions not free to move?
And I'm not sure about this one for the second one.
Because ions are strongly bonded in a lattice. They
Oh
have their
yeah,
particular places that they cannot move from. Why? Because they are strongly attracted from all the sides, from ions of a different charge. Sodium has a positive charge and it is being attracted from all the oxide ions surrounding around it. So, of course, it won't be able to move from its position. So there
okay.
are no free to move ions or electrons to carry the charge, and the ions are bonded under strong forces in a lattice. This would
Yes.
complete the answer for both the marks.
So the 2 points are no free ions or electrons, and the ions are in a lattice structure.
Right, strongly bonded in a lattice structure.
So give a test to show that give a test to show that sodium oxide contains sodium ions. So what's the test for sodium? You can use the flame test, right?
Right, and the color would be?
Oh, color. For sodium, is it yellow?
Right, yellow. This completes the answer for 2 marks.
When sodium oxide is heated, it reacts to form sodium metal and sodium peroxide, Na2, Na2O2. Complete the equation for this reaction. Okay. So let me try and do this on my notebook.
Sure.
Sodium oxide is heated. X form sodium metal and sodium. Um, 2O2. So in this case, do I just write 2Na plus O2?
Sorry?
Do I just
No,
write 2Na plus O2?
no. That's not it. The products are written right in there in the question.
Sodium, sodium metal and sodium peroxide. Oh, so sodium peroxide is Na2O2.
Right.
Okay, so
And sodium metal is simply Na. So these are the
Na
two
and then
products.
I have to balance some. Okay. Two. There's 3 NAs. If I write two. Would it would I have to add the 2 at the start on 2Na2O? And then
Right.
that gives 2Na plus Na2O2.
Now you're correct. Good.
All right.
Okay.
Now question 7.
Question 7.
Yeah. This question is about soluble and insoluble compounds. A precipitate is an insoluble compound formed when solutions of soluble compounds react after mixing. Different solutions are mixed in separate test tubes. Okay. Which test tubes will a precipitate form? Copper sulfate solution and calcium chloride, magnesium nitrate solution, and potassium sulfate solution. Copper sulfate solution, sodium. Um, different precipitate. Only one, two. Is it all of them?
No, of course not.
Not all of them.
D is not the correct option.
Okay, so is it 2 and 3 only?
No.
Yeah, I don't know how to work this out.
Okay, do you remember the insoluble salts that we studied? You have specific set of insoluble salts that you need to remember from the book.
Oh, that table. I didn't. I forgot the whole table.
Okay, so let me tell you that all sodium salts, all ammonium salts, all nitrates, all ethanoids, all potassium salts are soluble. So what are the insoluble salts? It's an easier way to remember insoluble salts. Silver chloride and lead chloride are insoluble among chlorides. Among sulfates, barium sulfate, calcium sulfate, lead sulfate are insoluble among sulfates, and all carbonates are insoluble. Any carbonates are insoluble except three of them, and those three are sodium, potassium, and ammonium. Now, this would form copper chloride and calcium sulfate. There you go. Calcium sulfate is the one which is forming here. So one will form a precipitate. Now, next one would form potassium nitrate and magnesium sulfate. It's none of these, so it won't form a precipitate. Two is the one which won't form a precipitate. Now, talking about the third tube, sodium would form a sulfate and copper would form a carbonate. So copper carbonate is insoluble, so here it is. This is insoluble
Yeah.
in number 3 over here, which makes this the answer. C. Make sense?
Yeah, 1 and 3. Okay. So I need to memorize that table.
Right, you need to memorize the table in order to get these answers correct.
There's a lot of things I need to memorize in chemistry, right?
Right. Actually, in comparison to all the science subjects, chemistry has the most memorizable stuff.
Yeah.
That's true.
Can
Though you all also need to memorize a lot of things in biology and physics in comparison, but chemistry always has more memorizable stuff.
uh, in physics it's just the equations, and now they're going to give us all the equations in our exam.
Oh wow, that
So
makes physics way too easy.
yes, we just need to memorize all, like understand all the theory for physics now.
All right, that makes physics a lot more easier as compared to chemistry.
Exactly. Can you, is it possible for you to like make a PDF file of all the things I need to memorize for this, like for chemistry?
It would be a huge file. I can
It would be
try
huge.
that, but it would take me a few days.
Yeah, it doesn't matter as long as like it's before my chemistry exam.
Yeah, I might need to take 4 to 5 days in order to complete it.
Yeah, okay. That's okay.
All right, sure, sure. I can try.
All right, thank you. Yeah.
Welcome. Okay,
Um,
part B.
the next, okay. A student mixes solutions containing equal amounts of moles of silver nitrate and sodium chloride. The equation for the reaction between silver nitrate solution and sodium chloride solution is that see the color of precipitate of silver chloride. To remember the colors. Silver Right. Right. Um, I think silver chloride is the one. Would it be white?
Right, white. There were three silver salts that we were supposed to memorize. Silver chloride was white, silver bromide was green, and finally silver iodide was yellow. So yeah, you're right. Silver chloride is white.
Yeah. Okay. And then
Okay.
yeah. Oh, 5 mark. Okay. The student wants to obtain pure dry crystal and dry crystal of sodium nitrate. Crystals of sodium nitrate decompose at temperatures above 300 degrees Celsius. Describe a method the student could use to obtain pure dry crystals of sodium nitrate. Okay, so he wants to obtain the crystals. So straight away, I think he should first filter the sodium nitrate, and then after that he can um, heat it until like l- no, but it would be 300 degrees Celsius. That's too much energy. Can I heat it up to 300 degrees Celsius?
No, you should keep it lower than 300.
Oh. Mm. Isn't you have to heat it at lower and like heat it slowly for the crystals to form,
Right,
and then you leave them to dry in a warm place. I remember
right.
that be 2 marks. Um, what else can I include?
You're done for 4 marks. There is only a mark remaining.
Um, is it in the middle of the whole process?
No, actually, the beginning of the process
Also before filtering?
before filtering. Sure.
Oh, 10 pure. I'm not sure what the first point would be then.
You're supposed to start with a saturated solution of sodium nitrate.
Oh, so, oh, okay.
So it's better to filter a saturated solution of sodium nitrate, or first form a saturated solution of sodium nitrate and then filter it.
Okay, so,
The rest was correct. Filtration. And remember, the evaporation of water to heat it up, you don't need a higher temperature such as 300 degrees centigrade. Usually, the evaporation of water requires anywhere in between 90 to 110 degrees centigrade. So that's good enough. That's fine. So you can easily heat the solution in order to evaporate the water. You would hardly be using 100 or 102 or 103 degrees centigrade temperature, which is far less than 300 quoted in the question. You can simply write evaporating water, since evaporating water does not require any more than 100 degrees centigrade. So even if you don't mention any temperature in here, it would still be correct. However, if you mention temperature, that's not wrong either. That's also a good approach.
hmm, okay, so can I tell you my answer to just make sure I would get the 5 marks?
Sure. Go ahead.
So I had heat the sodium nitrate until it's a saturated solution, and then filter the solution, and then heat the solution slowly until all the water evaporates, and then filter the solution slowly until all the water evaporates. Would that be the 5 marks?
Can you repeat your answer starting from the heat dissolution on slowly to form crystals part?
Heat the solution until all the water evaporates, and then crystals should start forming, and then after the crystals have formed, leave them to dry in a warm place.
Okay, just cut the word all from there. You cannot
Okay,
evaporate all the water before the crystals start forming because crystals start forming way before the whole water evaporates. That's why you go
okay,
with the drying step. So just cut the
yeah,
word all and the rest is correct.
okay,
Let me tell you, if you look at the marking scheme, you'll find washing of crystals after drying, and then they dry the crystal again. If this happens, this is an optional process. This does not include as a part of 5 marks for this
okay,
specific question. You're already done with the 5 marks, right? Remember,
yeah,
you wash the crystals for a substance which has hydrated salt, which has water as a part of its formula. For example, this is a simple sodium nitrate. Let's suppose if we're talking about a salt which has the formula written along with the water molecules, then remember, after you're done evaporating water and drying of the salt, you wash the crystals again in order to give them the water they require to form the whole salt, and then you dry them again. So you dry them twice. You dry them first, you wash them with distilled water, and then you dry them again.
okay,
All right. But for this specific question, as there is no water molecules attached, this is simple. You can just dry it and then you're done with all 5 marks. I hope that makes sense, right?
yeah, yeah,
Good. Moving on.
okay. So then question is, give an advantage of mixing solutions containing equal amounts in moles of silver nitrate and sodium chloride. Mixing solution containing um solutions. None of the solutions are wasted. Would that be
Perfect.
advantage? Yeah.
Perfect. That's correct. None of the solutions are wasted as a residue on the filter paper. Would be a much better answer. Means you give the examiner the idea that they won't be wasted, and you also give him the idea that if they are wasted as a residue on top of the filter paper during the filtration process
On top of the filter paper. Okay. Yeah.
as residue. The term we
Yeah.
use is residue.
Yeah. Yeah. Okay. Okay. So question 8.
Organic
The table.
chemistry.
Yeah. The table shows the structures of 6 organic compounds. True. Give the letter of a compound not shown as a displayed formula. Not shown as a displayed formula. That would be compound A,
Right.
and then give the letter of a saturated compound with the general formula CnH2n. Okay, so saturated. Saturated means they have just single bonds. Um, and Cn2n. That would be D. Yeah, D.
How come?
Because it has CN to H2N.
No, of course not. Actually, D is CnH2n plus 2 because that's C4H10. CnH2n means it has to be C4H8. D has 10 hydrogen, not 8 hydrogen.
Yeah, so it's not that. Yeah. Wait, C2H. T6. Okay. So it's not that. It's 6, 5. Oh, it's C.
It's C, right?
Okay. Okay, then name compound E. Oh. Okay, so I can see that's unsaturated. So it's an alkene. Um, it has 3 carbons. So it's meth, eth, pro. Would it be propene?
Right.
And then explain why compound A and compound D are isomers. Compound A. Oh, they are isomers. They are the same element just drawn differently or like displayed differently with a different structure.
This would get you 1 mark, but not the other. There is
What would
one
be
thing that we need to mention in specific when we're talking about isomers in organic chemistry. You're right about them having different structures, but what is same in isomers?
same in isomers? They have the same number of carbons. Um,
This is known as molecular formula. So they have same molecular formula, but different structure,
oh, so that would be the second mark.
right? Same molecular formula, first mark, different structure, second mark. Molecular formula means all the atoms have the same number in both of the structures. Because both A and D have the formula C4H10. They have 4 carbon and 10 hydrogen atoms each, but they have different structures.
Yeah. Okay. Okay. Yeah. Next
All right.
question would be compound F reacts with bromine in presence of ultraviolet radiation. Complete the equation for the reaction. We did this last time.
Right.
Um, so
The only
bromine gets
difference is that we used chlorine instead of bromine, so this shouldn't be difficult for you, right?
yeah, probably. Hopefully not. Wait, let me
Okay.
try.
Okay.
So, so would it be CH 2Br?
Okay, what else? Because there are more than one products in the system.
Yeah, and then for plus see 2Br. So and then the second product would be B H2Br.
Okay, there is a mistake in this because the correct formula would be HBr. There's only
HBr.
one hydrogen atom
Yeah,
being
only
combined
one
with one
hydrogen.
bromine.
That was my miscalculation. Okay.
This would also
So
change the formula of the previous product. So the correct formulas would be
of the previous product, what do you mean by the previous product?
means
It's C
CH2Br
CHR.
is also not correct.
CH3Br.
Right.
Yeah,
CH3Br plus HBr.
yeah. I think I made just a silly mistake there. Okay.
Yeah, you took two hydrogen atoms at the same time, which does not happen in one step. It actually happens in two steps.
Yeah. Okay. Give the name of this type of reaction. Um, isn't it like called additional something? An additional reaction?
No, addition reactions were with alkenes. This one is an alkane.
Um, so would that be substitution?
Substitution, right?
Yeah, substitution. Okay. And then another compound G has this percentage composition by mass. Okay. Show by calculation that the empirical formula of compound G is C2H4Cl. Okay. C2. Let me try to do this on my notebook.
Sure.
C. Six times. Can you help me out with the starting of this because it's hard. I don't understand how I'm meant to find the moles with just percentages.
So 37.8% for carbon. For hydrogen, this is 6.3%. For fluorine, this is 55.9%. So what we are
Yeah.
supposed to do is to simply convert them into grams by just changing the symbol. That would be our very first step.
Also, it's
And
also I
then,
use that as a mass.
yeah, you use that as a mass and
Oh,
an
I will,
AR, which for
now I
carbon is,
understand. Okay, now I can do it. Yeah.
From here on onward, it's pretty easy.
Okay, so I got it now. Yeah. Um.
And is it same as stated in the question?
Yeah.
C2H4Cl,
Yeah. Runs up to all. Yeah.
2, 4, and 1, right?
Yeah.
Good, good. Then we can continue with the next part.
I just had to divide everything by 1.57 because that's what the mole for chlorine is. That's the smallest mole, so then I divide by the rest, right?
Completely understandable. Good.
The next question is the relative formula mass MR of G is 127. Determine the molecular formula of G. Okay, molecular formula. So another. So 127. 27. 60. 18. Is there an easier way of doing this?
Yeah, there is. Actually, there are only 2 steps to follow in this part.
I'm just doing trial and error for this.
No need for trial and error. Okay, from the first part, what you got was that the empirical formula is C2H4Cl. The first step you're supposed to do, and actually this is actually a prerequisite for the first step, is to calculate the masses. So this is 2 into 12 for carbon. This is 1 into 4 for hydrogen. And this is 35.5 for chlorine. And that's 24 plus 4 plus 35.5, which I guess is 63.5. I guess I'm right. You might want to check that with a calculator, but I guess I'm right. Okay, since the MR is 127, so what we are going to do is that we're going to find a number we're supposed to multiply all these subscripts with. So N is
Just two.
MR over empirical formula mass. And yeah, that's 2. 127 divided by 63.5, that's 2, which means C2H4Cl is supposed to be multiplied by 2, which gives us C4H8Cl2. And that's the molecular formula. Make sense?
Okay, yeah. Okay. Right, yeah, that makes more sense.
And even if you're going with trial and error method, remember this number can be 2 or 3 or 4 or 5. So what you can simply do if you're stuck in exams, you don't remember these steps. So try multiplying the whole subscripts with 2. If the mass is equal to this, you get your answer. Try multiplying them with 3. Then if the mass is equal to this, you get your answer. Try multiplying by 4, and usually you get your answer with 2, 3, and 4. They don't give you bigger numbers in an Excel
Oh,
exams,
all right.
right?
Yeah.
Okay. So this is C part 3. Do you need to take a screenshot before I erase it off and move to the next question?
No, it's fine. I
Okay.
understood this one.
Okay. So I think, yeah, the last part of this question, next page, D1.
Okay, yeah. Compound E is used to make an addition polymer. Complete the equation to show part of the polymer formed from two molecules of compound E. Give one problem. Oh, that's the first part. Okay. Equation to show. Okay. Complete this equation. Okay, so I just need to annotate this. Should I do on the Zoom screen to show you?
Sure, sure. Go ahead.
Okay. Um,
The
mm,
annotations are already on.
yeah. Okay, so it says 2 here. That means this whole thing is multiplied by 2.
Right.
Okay. So there would be 1, 2, 3, 3, 4. That opens up 1. Okay. So I can fill out some hydrogens. Now, would I need to add another organic compound? Because so 2 times 3 carbons is 6, and here is only 4.
Which means you're supposed to add carbon atoms to this diagram.
Oh, okay. 4. So see, okay, that's 1, 2. Okay, so can I can add them like that, right?
No, actually you can't. You can't add carbon atoms to the main chain. You can add them as branches, but not as main chains.
Oh, okay. So I'll just
Which means you can add the carbon atoms either
I'll
on
put
top or
here.
at bottom, but
Yeah.
not horizontally in the same line.
So I'll just add that there. Same for this. And then I can add hydrogens to this, right?
Right, you can. I would suggest keep it like a condensed structure, not as a displayed formula, because usually when we write polymers, we write condensed structures, not the displayed formula. This would make the whole thing messy and a lot bigger than expected.
Okay.
Yeah, that would be a much better way of writing it.
So yeah, that would be all the carbons done, and then I have 7 hydrogens already. And I need 1, 2, 3, 4, 5, 6, 12. Okay. I think I just fill all this out and I get all the hydrogens, right?
Right. But you still won't get the correct answer. Because
Why so?
there are a couple of problems with this structure. The first thing is symmetry. The symmetry hasn't been followed.
What do you mean by symmetry?
Okay, let me explain. Now, there was a prerequisite, you can call it a middle step, that I taught you before you get to this part. Okay. Before you get to this part, I asked you to convert it into a structure like this, because this would always help you to do it right. So these two doubly bonded carbon atoms, this one and this one. So this carbon atom has 2 hydrogens, so I'm going to write 2 hydrogens just like this one. But this carbon atom is different. It has 1 hydrogen atom and an entire carbon methyl branch. So 1 hydrogen and 1 CH3. Now it's entirely up to you whether you write hydrogen on top and methyl at bottom, or you write hydrogen at bottom and methyl on top. It does not matter. Both ways it remains the same. It gets you good marks. So this is the actual structure, right?
Okay. Yeah.
And let me redraw this point sign, which gives us the idea that this thing is not correct. Okay, I'm going to erase it and I'm going to rewrite it like this. And let's use a different color. So 1 hydrogen and 1 hydrogen for the first carbon, and 1 hydrogen but 1 methyl for the second one. And this symmetry has to be maintained on the second molecule. So this is the second molecule, which is pretty identical to the first one. I call it a maintenance of symmetry, like this. And now what you're supposed to do is to intersect these brackets so that you can call it continuation, like this. Actually, even if you don't do that, that's fine.
Okay.
Right? Sometimes students also put an n over here. Since there is a 2 over here, writing an n won't make sense. So this would be good now without writing the n. This would be just 2 molecules of a very big polymer. So this is just a depiction. This continuation, this intersection means that the chain continues both on the right and on the left-hand side for a very big molecule. So it's always better to write it diagonally like this, with a carbon-carbon double bond right in the center before you convert them into a polymer, because this would help you to maintain the symmetry, to keep all the elements or the atoms intact at the places where they're supposed to be. Make sense?
Kind of, yeah.
So try always writing your alkenes, doubly bonded structures like these, in this form.
Okay.
Always in this form, because this will then help you to convert it into this form. See,
Okay.
since I took these two and I put them over here, and then I took these two and I put them over here, like this. So it helps. It always helps you to get the right answer.
Okay. Yeah.
All right. Last part of
So,
this question.
give one problem caused. Wait, I need to stop on it. Yeah, okay. Give one problem caused by disposal of addition polymers. Give one problem. What's addition polymers? Addition polymers. I'm not sure about this.
Addition polymers are actually plastics. Can you come up
Oh,
with one problem caused by disposal of
yeah,
plastics?
I already thought about this, but I wasn't confident in it. Is it because they're not biodegradable?
Right, they're not biodegradable. Perfect, a good answer. You may write not biologically degradable, or you may write land pollution, you may write filling up of landfills, you may write water pollution. So there are many problems that they cause. Writing either one of those would get you the mark. Okay, so would you like me to continue? Because it's already more than 2 hours.
Uh, We reached 2 hours, so I think we'll continue another time.
Sure. Keep
I
the
may
file.
go
If you'd
through,
like to try it on your own, that's entirely up to
yeah,
you.
I might go through it like later on in the day or sometime.
And you can send me
Is
the
there a mark
pictures. We
scheme
can
to it?
discuss it.
Yeah. Is there a mark scheme or anything so I can be checking while I'm going through it?
I don't have it on me right now, but I can send it to you in a few hours.
Yeah, all right, yeah. And if
Okay,
there's
good.
any like anything I don't understand, I can send it to you through WhatsApp.
Sure,
All right, yeah.
no problem.
Okay, thanks.
Welcome. Bye.